Dear learners, welcome to the next module, that is wind turbine components. As we know that wind is air in motion. Wind is mainly formed due to Earth's rotation and the uneven heating of Earth's surface by the sun rays. Wind contains a vast amount of energy which can be harnessed using wind turbines. If we talk about a wind turbine, it is a system which transforms the kinetic energy available in the wind into mechanical or electrical energy that can be harnessed for any required applications. Mechanical energy is most commonly used for pumping water, whereas the generated electricity can be utilized locally or transported to the desired location through grid. Dear learner, before starting the wind turbine components, we have to understand the basics of wind energy theory and practice. Under this category, following parts play a major role. First one is lightning rod, second one is lattice mat mast, third one is cup anemometer, next weather vane, and the last one power cable and data cable. We will discuss each and every component in upcoming videos. Moving on to the types of wind turbines, horizontal and vertical axis wind turbines are two main types of wind turbines used to harness wind energy for generating electricity. Each type has its own design, operation and advantages. First we will discuss horizontal wind turbines. Horizontal wind turbines have blades that rotate around a horizontal axis, similar to the blade of an airplane, propeller. Key features and benefits include design. In design section, blades are positioned on a horizontal shaft, often mounted on a top of a tall tower. Then efficiency, generally more efficient at capturing wind at higher altitudes, where wind speeds are higher and more consistent. Third one is scalability. This can be utilized in various sizes from small residential turbines to large scale industry turbines. Next, technological advancement. Well established technology with continuous advancement to enhance efficiency, reduce noise and improve durability. Next one is location flexibility. Can be installed in a variety of locations including onshore and offshore depending on wind resources. The second main component is vertical wind turbines. Vertical wind turbines have blades that rotate around a vertical axis, or we can say reassembling an egg beater or a helix. Key features and benefits include, first one is design. The blades are designed positioned vertically, allowing for a smaller footprint and less land usage compared to horizontal turbines. Next, low wind speed operation, capable of capturing wind from multiple directions and operating efficiently at lower wind speeds, making them suitable for areas with inconsistent wind patterns. Aesthetic appeal, often considered more aesthetically pleasing and less intrusive compared to large horizontal turbines, making them potentially more acceptable in urban or populated areas. Next is low maintenance, generally simpler in design and mechanics, leading to potentially lower maintenance cost. Next is easy installation, easier to install due to their design, which can be installed on shorter towers and without the need for complex yaw mechanism. In summary, horizontal wind turbines are known for their efficiency at higher altitudes, scalability and continuous technological advancement. On the other hand, vertical wind turbines offer advantages such as sustainability for lower wind speed, aesthetic appeal, lower maintenance and ease of installation. The choice between horizontal and vertical turbines depends on the forces such as wind patterns, locations, available space and specific project requirements. There can be different turbine technology options which are as follows. First one is for axis orientation. Either horizontal or vertical orientation can be chosen. Second, for power control. The options available are stall, variable pitch, controllable aerodynamic surfaces, yaw control, etc. Next one is yaw orientation. It can be driven yaw, free yaw, fixed yaw. Next one is rotor position. Can be chosen as upwind or downwind. Then transmission can be done with gear or without gear. Type of hub can be rigid, tethered, hinged blades or gimbaled. Then generator speed can be constant or variable constant speed type. Next one is number of blades, can be 1, 2, 3 or multi-blade. And the last one is location, can be chosen as onshore or offshore. Now we will discuss wind turbine components. First one is blades. Most turbines have 3 blades. The turning of the blades generate electricity. Second one is hub. Center of the rotor to which the rotor blades are attached is called as hub. The next one is rotor. Blades and hub referred together in a machine type which is known as rotor. Low speed shafts connects low speed shaft to high speed shaft and increases rotational speed from about 30 to 60 rpm to about 100 to 1800 rpm. Next is generator. It produces electricity. Then high speed shaft drives generators. Then controller stop and shut down the wind turbines machines. Then after anemometer, which is used to measure the wind speed and transmits wind speed data to controller. Next one is wind vane, measures wind direction and communicates with yaw drive to orient the turbine yaw drive. Next one is yaw motor, keeps rotor facing into the wind as wind direction changes, powers yaw law. Next one is nacelle. Nacelle is the very important part of wind turbine component which contains gearbox, low and high speed shafts, generator, controller and the brake made from tubular steel, concrete to steel lattice, taller towers to generate more power. Next one is tower, which is made from a tubular steel, concrete or steel lattice. Taller towers generate more power. Pitch, blades are turned or pitched to control the rotor speed. Next one is brake. Brakes are used to stop rotor in the emergencies. Here you can see in the animation the complete working of wind turbine components.
The principle behind the wind turbines is very simple. The energy in the wind turns the blades around a rotor. The rotor is connected to the shaft, which spins a generator to create electricity. In this video, we will learn how a wind turbine works and generate electricity. A wind turbine has many components which collectively help in generating electricity. The wind runs through the turbine blades, thus decreasing the air pressure on one side of the blade. This causes a difference in air pressure through both sides of the blade, creating a force on the blade. The intensity of the force rotates the rotor. But the slow rotation speed of the blades is not enough to produce electricity. For this reason, a gearbox is connected between the rotor and the generator. This generator transforms the aerodynamic force into electricity. The housing holding the gearbox and the generator is called the nacelle, which can move according to the direction of the wind. If the direction of the wind changes, a velocity sensor located on the top of the nacelle sends a signal to the yawing mechanism at the base of the nacelle. This mechanism then moves the blades to face the proper wind direction. Also, the blades can rotate using a blade tilting mechanism to align itself with the proper angle of the wing. In this way, wind turbines can convert wind energy into electricity.
This video is taken from Let's Grow Up YouTube channel. So dear learner, now we will learn about the relationship between wind speed and power production. The relationship between wind speed and power production in wind turbines is a fundamental. Wind speed directly affects the amount of power generated by a wind turbine. As wind speed increases, the power output of the turbine grows exponentially. The power produced is proportional to the cube of the wind speed, following a cube power of law. This means that even a small increase in wind speed results a significant boost in power production. Conversely, if the wind speed decreases, the power output drops rapidly. Therefore, maximizing wind turbine efficiency and harnessing optimal power requires placing turbine in areas with consistent and strong wind speed, where they can operate at their peak performance and contribute significantly to renewable energy generation. So dear learner, now let's discuss the main features of different types of wind turbine. First one is horizontal axis wind turbine. So we will just learn the brief points, that is upwind design, most common and widely used, blades rotate around a horizontal axis. Now second is vertical axis wind turbines. Under this category, blades rotate around a vertical axis, less common but gaining interest. And the last one is suitable for various wind directions without needing to turn into the wind. And the last one is Darius wind turbines. Under this category, type of vertical axis wind turbine with curved egg beater like blades self-starting capabilities, often used in smaller scale applications. But now the last but not the least, that is Savonius wind turbines. Another type of vertical axis wind turbine with curved S-shaped blades, simple design, robust and easy to manufacture, typically used in low wind speed environments. Next is hybrid wind turbines. The combined features of both horizontal axis wind turbines and vertical axis wind turbines aim to capture wind energy efficiently from various wind directions. Less common but being explored for increased efficiency and versatility. Each type of wind turbine has its own advantages, drawbacks and ideal applications based on factors such as wind conditions, location, cost and intended use. In this picture, you may see the different types of towers used in wind turbine. We will discuss them one by one. First one is tubular steel tower. The area of contact is more, hence more loading but evenly distribution attractive and cost is more. Second one is tubular concrete. Under this category, area of contact is more, high elasticity, loading high but even distribution, cost slightly less. Third one is lattice tower. Area of contact is less loading, load distribution is uneven and transportation fabrication is easy. Fourth one is three-leg tower. Area of contact is less loading, load distribution is uneven, transportation fabrication easy. Guy wired tower. Area of contact is less loading, load distribution even, transportation fabrication easy and not suitable for huge wind turbines. The last one is hybrid tower, a combination of tubular and lattice, less obstruction and strong. So dear learner, in the next topic we will understand the wind turbine generators. A wind turbine generator is like a massive windmill. Instead of pumping water like a traditional windmill, it uses the wind energy to generate electricity. Imagine a big fan on a lower. When the wind blows, it makes the fan's blades spin around. Here is we learn how it works. First one, catching the wind. The wind blows and pushes against the turbine's blades. The blades are designed to catch the wind and start spinning. Second one is spinning blades. When the wind makes the blades spin, they turn a part inside the turbine called a rotor. Third one is rotor and generator. The rotor is connected to a generator where is like a magic box. Inside the generator, the spinning rotor creates something called electricity. The energy we can use to power our homes, schools and other places. Fourth one is electricity production. As the generator works its magic, it produces the electricity we need. This electricity is then sent through power lines to our homes, where we can use it to turn on lights, run applications and change our devices. So, a wind turbine generator is like a super tall windmill that helps us turn wind into electricity, making sure we have the power we need to make sure our lives easier and more comfortable. Now, general setup needed for wind turbine measurement. Setting up to measure wind for a wind turbine involves a few important steps. First, we place anemometer where are special devices that look like small propellers at different heights on a tall tower. These anemometers measures the wind speed and direction of the wind. We also have wind vanes that helps us figure out where the wind is coming from. All these equipment is connected to a computer that collects and stores all the wind data. Sometimes we even use weather balloons to measure wind at higher altitudes. This setup helps us understand the wind patterns and strengths, helping us decide the best places to put wind turbines for making electricity. It's like setting up a weather station but specifically for wind. Wind turbine turbulence can have significant effects on both individual turbine components and the overall performance of a wind farm. Turbulence in the wind can be caused by various factors, including nearby obstacles, changes in wind direction or speed, and atmospheric conditions. Here is how turbulence impacts wind turbines and wind farms are. The first one is impact on turbine components. First one is blade. Turbulence can cause uneven forces on the turbine blades, leading to increased stress and fatigue. This can be shorten the lifespan of the blades and may necessitate more frequent maintenance or repairs. Second one is tower and structure. Turbulence can also affect the tower and the other structure components. The tower can experience additional stress due to turbulent wind, potentially leading to structural damage or fatigue over time. Next one is gearbox and generator. Turbulence can cause fluctuations in wind speed, resulting in variable loads on the gearbox and generator. This can affect their efficiency and overall performance. Impact on wind farm performance. Power output variability. Turbulence causes variations in wind speed and directions across a wind farm. This variability can lead to inconsistent power output from individual turbines and the wind farm as a whole, impacting the stability of the power grid. Next is wake effects. Turbulence in the wake or one turbine can affect nearby turbines, reducing their efficiency. Turbulent wakes can disrupt airflow to downstream turbines, causing them to generate less power. Now, dear learner, we will discuss about the impact on wind turbine performance. First one is power output variability, second one is wake effect, and the last one is array efficiency. To address the challenges posed by turbulence is, first one is wind turbine designs are constantly being improved to withstand and integrate the impact of turbulence on the components. Second one is advancement control systems can help turbines adapt to changing wind conditions, optimizing their performance and minimizing stress components. The third one is wind farm layout and spacing are carefully planned to minimize wake effects and optimize energy production. Understanding and effectively managing turbulence is crucial for maximizing the efficiency, longevity and overall performance of wind turbines and wind farms. These are contributing to a sustainable and reliable renewable energy sources. Now, we will see the role of the wind resource assessment in a wind farm. Imagine you are outside on a windy day and you notice how strong the wind is blowing. Wind resource assessment is like measuring and understanding how strong and reliable that wind is in a specific area. Here is how it works. Apart from this, National Institute of Wind Energy and Ministry of New and Renewable Energy, that is MNRE, has notified the repowering policy for old wind farms. By installation of modern wind turbine, the performance and efficiency simultaneously increases with same research site with number of wind turbines. Thank you.